Okay, let's talk about interest and specifically compound interest a little bit more here. Our interest is money that our money is making us, so we like that. And then interest on interest or compound interest is where the money that we invested or that we've saved is making us interest, and then the interest that we've been paid makes us even more interest. So it's interest on interest. Compound interest is awesome if you're receiving it. Let's look here at the example. Would you rather have it compounded daily or monthly? The extra dollar you're making from the money making you money is very, very helpful. You'll see that it compounds up nicely. So the example here, a very simple example, is $100 at 10% compounded annually would give you $110 at the end of year one. Obviously, 10% of $100 is $10, so it's $10 interest added to your principal, you would have $110. The second year, however, you don't get $10 interest because you get interest on your interest. So $110 at 10% is $11, and that would equal $121 in year two. So you can see that the interest, the compound interest is accumulating, the interest on the interest, and then we can take it over a longer period of time. It should add up to quite a bit of money. Let's look at the next chart, which is the effect of compounding. The effect of compounding the first year is, this is annual compounding. $100 goes to $110 the first year, $121 the second year, $133.10 the third year, $146.41 the fourth year, and $161.05 the fifth year. So the $100 gives you $10 interest the first year, $11 interest the second year, and then even more interest, $12.10 on the third year, and so on. So you can see that compounding is something we like to do. Now you could sit there with this simple math and figure this out, but clearly there are going to be problems harder than that. So you have to start thinking about a little bit more complicated problems. So for example, here's a problem. If you invest $5,239 today at 4.53% compounded annually, how much would you have in 5 years? Well, we could sit down with a calculator and probably figure this out. We draw maybe a timeline. I think timelines are very helpful in time value of money. And so we draw this timeline and we just do it step by step. Maybe that would look something like this. So we draw our timeline for clarity. We start with 5239 at times 0. That's today. We have 4.35% annually, and the future value is what we're looking for. So the present value today is 0, or is 5239 at times 0, and we just multiply it out 5 times. Now, if we take this step by step, the calculations would end up looking something like this. 5239 and then 5239 times 1.0435, which is 4.35%, plus of course the principal again. So you got the principal is 1.0, and then the 0.0435 is the additional interest. So the 5239 would turn into 5466.90 the first year. And then you'd have to do it for the second year, third year, fourth year, fifth year. You'd end up with 6482.02. Now you could do this math. There's no reason why you couldn't. I mean, obviously a calculator would be easier, but you could do it longhand if you really wanted to. Now, if you just algebraically spin it a little bit, you get 5239 times 1.0435 to the 5th power. So if you wanted to do it that way, that would be simpler. Obviously, a calculator would help, and you could do it that way. So you can compound it up or just take all of the additional interest and multiply it together, and then multiply it by the amount, and you could do it that way too. I think both ways are somewhat challenging. So I think it's much easier to use a financial calculator or a spreadsheet to do problems like this. The other thing is we've compounded it up. So we started with 5239, and we've compounded it up. What if we wanted to know how much we have in the future? We had a bill we had to pay, for example, and we wanted to save up for it. How much would we have to come up with in the present? So we compounded it up. Well, if we have future value, we can do what's called discounting, or discount it back to find the present value. So the future value, obviously future value, present value is where we started, times 0 or right now. Future value, present value, we can move up compounding, we can move back discounting. Discounting looks like this. Instead of multiplying, we divide. So the 6482.02 divided by 1.0435 equals 6211.81. And you just could keep doing that, or you could just divide 6482.02 divided by 1.0435 to the 5th, and you would get 5239. So you can compound up and discount back. Doesn't matter which way you go, it would be the same math. You either are multiplying up or dividing on the way back. Now, this is one way to do it, but it is a very tedious way and certainly not what you want to do. In fact, if you look at this, this was compounded annually. What if it was compounded monthly or compounded daily? The graph you see here is compounded monthly. Imagine daily how many times you'd have to calculate this. Clearly, we're not going to do it this way. So stay tuned, and I'll give you a much simpler way to do compounding and discounting.